what is the largest value of x for which 60 factorial over 3 to the x is an integer. So again, we have 60 factorial over 3 to the x, and we have this enormous number up top, and we want to know how many 3's we can put on the bottom. In order to answer that, we have to figure out how many 3's are up top in 60 factorial, and so we need to prime factor the factorial. Okay, so that's our goal over here, to prime factor this factorial. Once we prime factor the factorial, we'll figure out how many 3's it has, and then we can see what the maximum value for x would be. Now, just to review, a factorial is, so when we have 60 factorial, what we have is 60 times 59 times 58 times 1. And so one way to prime factor this is to just do it the long way, but obviously that's going to take a day and a half. So prime factor 60, 59 is already prime, 58 is 2 times 29, 29 is prime. But this is going to take forever if we do it the long way, if we do it if we prime factor this number the regular way. However, there's a shortcut when you're dealing with factorials, when you're dealing with these numbers where you're just multiplying down to 1. The shortcut is the following. And I'll use 60 factorial as an example. So if we're prime factoring a factorial, we take a look at the number that is being factorialized. So in this case, it's 60. And we ask ourselves, how many times does 2 go into 60? Well, 2 goes into 60 30 times. Then we ask ourselves, how many times does 2 squared go into 60? Well, 2 squared is 4. So what I'm really asking is, how many times does 4 go into 60? And that's 15. Then we ask ourselves, how many times does 2 cubed go into 60? Well, 2 cubed is 8. And so how many times does 8 go into 60? It goes into it 7 times with a remainder of 4. Then we ask ourselves, how many times does 2 to the, so that's 1, 2, 3, 2 to the 4th go into 60? Well, 2 to the 4th is 16. 16 goes into 60 3 times, it's 48 with a remainder of 12. And as you see the pattern, so how many times is, so this 1, 2, 3, 4, how many times does 2 to the 5th go into 60? 2 to the 5th is 32. Oops, not 3 squared, 32. 32 goes into 60 just once with a remainder of 28. And finally, how many times does 2 to the 6th go into 60? So 2 to the 6th, and the reason I say finally is because 2 to the 6th is bigger than 60. 64 goes into 60 0 times. When we hit 0, we stop. What we then do is we add up all of these quotients. So 30 plus 15 plus 7 plus 3 plus 1. So 30 plus 15 is 45. 7 plus 3 is 10. 45 plus 9 is 55. Plus 1 is 56. What this tells us is that 60 factorial has 56 2's in it. We've now figured out, we've partially prime factored 60 factorial. We figured out how many 2's there are using this shortcut. And we'll use the same shortcut for figuring out how many 3's there are. So we'll start the same way. So 3 into 60 is 20. Then 3 squared, which is 9, into 60. Let me write that as 9. 9 goes into 60 6 times with a remainder of 6. 3 cubed, which is into 60. How many times does 3 cubed go into 60? Well, 3 cubed is 27. Into 60 goes twice. It's 54 with another remainder of 6. Then we have 3 to the, so it's 1, 2, 3, 3 to the 4th. How many times does 3 to the 4th go into 60? Well, 3 to the 4th is 81. 81 does not go into 60, it goes into it 0 times, and so we stop there. We then add the dividends, not dividends, quotients, 20, 6, and 2, and we can see that 60 factorial then has 20 plus 6 plus 28, it has 28 3's. So again, we've, so the old way that you normally do prime factoring when you have something like this is you prime factor each of the numbers individually. What we're doing here is we're working sort of backwards. We're asking ourselves, we're starting with the primes and thinking how many primes how many 2's go into this factorial, how many 3's. The next one would be 5. So let's do that just to practice, but we actually, in the interest of this question, we don't need to do that. The question is not asking us to totally prime factorize 60 factorial. It's just asking how many 3's there are. We figured out that there's 28 3's. But just to practice, we have here, we would say, okay, well, to find out how many 5's there are in 60 factorial, you do 5 into 60, and that's 12. Then you do 5 squared into 60, it's 25. I'm not going to erase it. It's 25 into 60 is 2 with a remainder of 10. Then we have 5 cubed into 60, which is 125 into 60, that's 0, and we stop there. As you see, as the primes get bigger, we have less and less of them, so, or fewer and fewer of them. So when you add up 12 and 2, what we get here is 5 to the 14th. And we would actually keep, we would continue to prime factor using this method. Very quickly you get to primes that there's only one of until we get to 59 is the last prime in here because it's the closest to 60, and that's raised to the first. But the question is asking how many 3's there are. We figured out there's 28, and so the answer is D.